Hi, this is Stephen Wing's presentation of practice problem 4, a mini presentation on workshop 2. Now, workshop 2 is defined as a random size matrix M of integers, and given an integer value of V, is there a square matrix within that rectangle M whose values add up to V? So, first part is the code itself. What I did was I created a program that should simulate the same thing. It should check for all possible sum of search squares within that matrix that will that matches with search value V, right? And how I did that compared to the original brute force is this is complete brute force. It searches for each one of the cells and then searches for search squares from each individual cells as a search index, and then gives you a yes or no and searches until you get a yes or a no, right? What I did here instead is I created two submatrices, one of horizontal sums and one of vertical sums. So depending on the size of your search square, it'll add up those number of values and then define the first value of the submatrices as that result. So for example, if I search by 1, the first value of the submatrix for horizontal would be 0. If I search for 2, it would be 0 plus -2. If I search for 3, it would be 0, -2, -7 added together, and that would become the first cell, right? And so you should have shrinking submatrices because these sums are defined by the size of the search square. Same thing for vertical, 0 or 0, 9, 0, 9, -4, so on and so forth. And you go through each search index and create smaller submatrices, and then you make them run through each function. So you go from the horizontal to the vertical, and then you have a total sum submatrix. And then you can search through that submatrix for the answer, right? So in this situation for test my matrix, right, we go through test. What I have here is that for any given current size, and I make it run through each one of these for every current size that is possible. We make it go through all the horizontal sums first, then the vertical sums afterwards, and then the result should either be true or false, right? And this isn't complete, this isn't full yet, but this is the idea that it should run through. Now, when I search through these submatrices, right, I go through horizontal and vertical, the time complexity should be smaller because I'm running these additively. So I run through these for loops. So one for loop, two for loop, three for loop, a time complexity of to the power of 3, same as this, but it doesn't become the power of 5 as similar here with 5 concurrent for loops going through here. It's just n to the power of 3 or xy to the power of 3, right? The summation power of 3 to this point. And then, of course, you have the final for loop here, which can cause you to have to search through, but that's a power of 2. You have 2 for loops here. So the larger one is to the power of 3. You've lowered the complexity. Now, as for space complexity, I believe it should be a variation of x and y to the power of x times y, or a 2 power, because you have 2 subarrays. Subarrays are x times y. That's how much amount of space they need to take. But then you have 2 of them, so that's 2xy. It's just xy as a space complexity. As a proof of correctness, I'll be using a derivative of the brute force proof that we had used earlier in our previous discussion between me and you, Professor. And I will need time to formulate that in a much more concise manner, but it'll be a derivative of that. So thank you very much, and I hope this fulfilled the requirements of the assignment.